Okay, again, polynomial inequality. In this case, you put the inequality. This is the factorization already. Equal to 0. Therefore, x equal 1, x equal 2, and x equal 3. And this is the critical value. Let's do the partition of the number line. Or real number, infinity, negative infinity. The partition are 1, 2, and 3. And you select arbitrary testing point, get 0, is 1.5, is 2.5, is 4. Okay, let's do in the chart. This chart contain for testing 0, 1.5, 2.5, and 4. And the factor is x minus 1, x minus 2, x minus 3, and a total signs. Okay. Let's analyze one by one. 0 here is negative. 0 here is negative. 0 here is negative. 3 negative. Multiply is negative. So when you have the odd number of negative, it's negative. When you have even number of negative, it's positive. 1.5 here is positive. 1.5 here is negative. 1.5 is negative. 2 negative is positive. 2.5 is positive. 2.5 here is positive. 2.5 is negative. So we have a negative answer. 4 is positive. Is positive. Is positive. Therefore, it's positive. Okay, now our inequality is less than or equal to 0. So less than is negative. So the true part is negative part. This and this is the true part. This is false. And this is 4. I don't care. I only care the negative part. Negative part includes 0, so this interval is correct. And one more interval is correct. Is 2.5 when you have 2.5. This interval is correct. And include, of course, the endpoint. Include a bracket here, because 1, 2, and 3 are solution for the equation part. Remember, this is a non-strict inequality, and the solution for the non-strict inequality is equal. The solution of the inequality we can find using the chart, and or join with the solution for the equation that's 1, 2, 3. Because 1, 2, 3 belong to the solution. How you indicate that? Using the bracket. Now, the solutions. The solution set in interval notation is from negative infinity, comma, 1 bracket, union, bracket 2, comma 3. In set notation is the value of x such that x is less than 1, include 1, or x is in between 2 and 3, include above. Okay, perfect. Okay, 27. 27 again is polynomial inequality. It's already in standard form. You convert to equation to determine the critical value. Now this is factorable equation. The common factor is x squared minus 2x minus 3. And this is the trinomial. The factorization is x, 3 and 1. 3 and 1 is 3, 3 minus 1 is 2. Different sign, minus and plus. Okay, now the solution for this equation is 0, positive 3, and negative 1. Positive 3 and negative 1. Let's do in the partition. The partition is, this is 0, this is negative 1, and 3. 2, 1, 2, 3 here. Now select the testing point. Testing point is maybe negative 2, it's good. And between negative 1 and 0 is negative 1/2. And between 0 and 3 maybe 1 or 2, whatever, 2 and 4 after the 3. Okay, let's do in the chart. The chart is okay, the chart is testing point. Testing point is -2, is negative 1/2, is 2 and 4. And the factor that we have is 6, is 6 minus 3, and x plus 1. Okay, and 1 extra column total, que represent the total sign. Okay, ready to start. Negative, well, this is negative, it's obvious it's negative. X is only this plugging in, is negative 2 and negative. This is negative and this is positive. This is elementary. And a negative 2 here is negative. Negative 2 here is negative. 3 negative is negative. Negative 1 here is obvious it's negative. Negative 1 here is positive. Now it's positive, because we have two negative. Negative and negative is positive. 2 here is negative. 2 here is positive. Now there is total sign negative. 4 here is positive, and here is positive. Now it's positive. Our problem is greater than. Greater than is positive. Therefore, the true part is when it's positive. True and true. And this is false and false. What is the truth? The interval that we have 1/2. 1/2 is this interval, this true part. This is the true part. And one more is true. What is for this region, this interval? Of course, our inequality is a strict inequality. No equation, therefore, do not contain the critical value as part of the solution. Now the solution is the interval from -1, 0 union 3, infinity. This is equivalent to right. This is x such that x is in between -1 and 0, or x is greater than 3. Okay, 29, again, polynomial inequality. The first thing you should do is write in standard form. So right hand side must be 0. Now let's do the factorization. The factorization is x squared minus 1 greater than 0, and this is a difference of a square. And the factorization is x 1 plus or minus greater than 0. And this is our expression. After that, I convert it to equation. I solve this equation in order to find the critical value. I solve because the critical value are 0, this part, -1, and +1. This is the critical value. This critical value helps me to do the partition in the real number line. And we select the testing point. This is 0, +1, and -1. It's obvious that the good testing points are, well, I suppose que 2 is okay, -2, here is -half, this is +half, and this is 2. Now let's do in the chart. Testing point, -2, -1/2, +1/2, and 2. So we have, for example, x squared is a factor of our polynomial, x plus 1, x minus 1, the total sines. Let's evaluate. Well, this is a square, so obviously it doesn't matter if the value is positive or negative. This column is always positive because it's a square. -2 here is negative. -2 here is negative. Double negative, so even number of negative is positive. Negative here is positive. Negative here is negative. The total sign is negative. Half here is positive, but this is negative. Then is negative because we have only 1, and 2 is positive and positive. The answer then is positive. This inequality is greater than 0. That means it's positive. So the true part is when it's positive. Here and here, and this is false and false. Then the solution is this part with -2, and this part is positive 2. Of course, it's a strict inequality, because at the end point, -1 and 1, no, it's not part of the solution. Okay, then the interval solution is -infinity, -1, union 1, infinity. Que es equivalent x such that x is less than -1 or x is greater than 1.